and I am live and my screen is not stuck. That is cool. Yep, that is cool. And yes, not been, we haven't been making any progress in our journey about making this app because I have gotten stuck at a point, and that is this. First, I am unable to make my there are two things that I have gotten stuck at. First, I'm unable to make my IP global, global, and that is devices which are not in the local network as mine should be able to access it, but they have been unable to access some server that has been running on my IP address. So that is the first thing, one thing which is very necessary for me to do because I have to give my IP, give the IP and port to Google, which exactly points to a server that is running on my machine, which will capture the access token, which will be returned by Google when the user has authenticated. Right. So this is the first problem, and the second thing, which I have like already listed before, is that DDNS, DDNS, since the since my IP keeps changing because my IP is provided to me by my ISP, Internet Service Provider. They keep changing the prefix. That is, the ISP provides my router a prefix, just some of the starting bit of the full IP address, and the later part, which is not provided by the ISP, is put in by the router itself and to give different full IPs to every device that is connected to that router. Now, the ISP keeps changing the prefix for security reasons so that I do not have a fixed IP for my laptop for an interface on my laptop for security reasons. So either I can get a static IP address and pay for it so that I will have one static IP permanently, or I can use a DDNS service in which I will uh, give the access for my domain, DOMAIN, for my domain to a service which can change the IP to which this domain, SERVICE, which can change the IP to which this domain points to. That is, it can update the DNS, domain name service, for my particular domain. And this is called dynamic because I will be sending requests every 5 minutes to the service to update my domain to my latest IP address so that uh, I will have a single domain name which will always point to my current IP address. And how will that happen? There are daemons. Daemons are just programs which run in the background at the OS level. Some daemons come with the OS, or some daemons I can add myself. These are programs which do not require a user interface. They just run in the background and do not require an active terminal to be running. Uh, so yeah, there is a daemon called cron tab, which can be used to run to schedule a task to run at an at a interval. After a specified interval, it will keep iterating, and I can give it a shell script which will run after a period of time, every time that period happens, right? So I can give my write a shell script which will send a request to the service to update this, and yeah, every 5 minutes this will happen. There is a daemon called cron tab which can do this. But cron tab is more Unix, Linux based, and In Mac, there is another thing called launch D, which is a daemon called launch D. Daemon D stands for daemon, and which does the same thing, but I've been unable to make it do stuff that I want. I don't know why that is, but I have a better understanding of how to use cron tab, so I will be using cron tab for to run my shell script again and again to update my service. Now, the problem that I am facing is, first, I have been unable to solve this part, and second, I have been unable to solve this part. No, but that doesn't help. Why? Let's talk first about this. Why haven't my IP been global? Well, I have an IPv6 address, which means IPv6 addresses are generally, if they do not start with a certain prefix, and that prefix, I guess, is 80 something. I can just see it here. Not config, if config en 0 grep inet. Yep, if if IPv6 addresses start with FE0, then they are local addresses, but if they start with something else, then they are global addresses. So I do have global addresses. I have a temporary address, and I have a temporary address, which is this one, and kind of secured non-temporary access, but which also changes when my ISP changes the prefix. So I have two addresses, but when I give one of these address to a friend of mine, they are unable to reach the server that is running on my device. Now, there could be two things. There are like literally just two things which stand in the way of my service that is running on my computer on a certain port and my friend's laptop. From his side or her side, the request is coming. That is, we can assume that is true. Okay, so let's say call it computer A that is sending a request to me, B. So before reaching my laptop, it has to go through first the router to which my laptop is connected and is accessing the computer, and then after the router, it has to go through my computer's firewall. Um, how do you spell firewall? Yes, firewall. After the router, it has to go through my computer's firewall. So there are two things which I have to bypass. And the router's firewall, what was the thing? A router login. I have a geo router. Yep, 192 dot um, 192.168.2.19. Why is that the specific thing to access my router? I guess that points to the local address of my router. That is my best guess. That is the local address that points to my router. Yep. Local addresses in IPv4 begin with 192.168. Now, accounting. Well, I have a whole operating system in the router. That is just crazy. Input output is zero. I guess because I haven't connected any Ethernet or something. And memory is 53% empty. Huh. Content filtering is off. That is, I can receive anything, I guess. Uh-huh. Network status. I have a few things here. Device status, line clients, network, LAN, wireless. wireless. I don't know what I'm looking for. I'm looking for something. I don't know. I have AP name. Uh, okay. I don't know what that means. AP name. Then I have security. I guess that is what it is. Always allow always. That is crazy. And I have an IPv4 firewall rules, IPv6 firewall rules, inbound HTTP request always allow. Okay, that is port 80, right? And that is enabled. Inbound, I will always allow any inbound rule type inbound. I would suppose that means any incoming requests will be allowed from any source IP to any destination IP, my destination IP to from any source IP. That makes sense. And what is the second one? This one, service any. That is a bit more crazy. Uh, can I update it? Edit. Yep. Let's see. Inbound. Yep. Service. Can I not DNS? Okay. It says service. Does it refer to port number? Mm, do these different services refer to just port number? And if that is, can I provide a custom port number? Um, yeah, like HTTP on a machine is by convention run on port 80. Do other services like CDN and DNS is also service, would also, yep, DNS and CDN. There is no CDN. CDN or DNS also run on some specific port in their own protocol on a machine. Yes, shit, that is crazy. I didn't know that. Yes, just like HTTP runs on port 80 by convention, many other services have well-known ports assigned to them. Here are some ports. DNS domain name service. It uses DUDP. It does not use TCP. When okay, sometimes TCP for large queries. Okay, because it is just when accessing our DNS, all I want to know is what does this domain name point to? What is the IP address that this points to? So I guess UDP is much faster when what you want to get is smaller. So it runs on port 53. Okay. So DNS came before HTTP, I would presume, and CDN, Content Delivery Network, typically uses standard web ports. DN Oh, CDN is based on top of HTTP and HTTPS. Some CDNs also use TCP. This for RTMP, real time media protocol, I suppose. HTTPS runs on TCP on this port. FTP, file transfer protocol, runs on TCP at 21 port. And for control and this secure shell. A secure shell runs on top of TCP at port 22. SMTP runs on this port 25 on top of TCP. Incoming email retrieval and POP3 incoming email retrieval. They also have their own specified ports. MySQL has its own specified port. MySQL server, if running on a device, it has its own specified port. That is cool. And Postgres also has its own specified port. Redis, I'll have to know about Redis, what it actually means. But MS SQL has its own port. Okay, yeah. So these, okay, about CDN. So CDN is not a protocol per se, protocol per se, but a very specific use case of HTTP or HTTPS protocol where the uh, main objective is to transfer files. Question mark. Yes, exactly. CDN is not a protocol, but a service that optimizes content delivery using standard HTTP or HTTPS protocols. A CDN primarily focuses on efficiency, distribution, and caching static and dynamic content like images, videos, scripts, and even entire web pages across multiple geographically distributed servers. CDN is more like a concept which is built on top of HTTP. Okay, it relies on HTTP port 80 and port 443. Hmm. Yesterday, in the Socratic method, I read that do not try to take a conversation in a certain way. Well, when you are learning, take it free flow. So I wanted to know about CDNs, so I will learn about CDNs. And caching CDNs store copies of frequently accessed files, example images, CSS, JavaScript, on edge servers closer to the users to reduce latency. Load balancing CDNs distribute traffic across multiple servers to prevent overload, compression, and optimization. They often use techniques like gzip, broti, and WebP to optimize file sizes. Security. Many CDNs provide DDoS protection, web application firewall, and bot filtering. Comparison with DNS. DNS, domain name service, is an actual protocol that translates domain name example.com into IP addresses. CDN is a service that uses DNS based routing. DNS based routing DNS-based routing to direct users to the nearest edge server for fastest delivery network. Okay, let's go back to first principles, what they are saying. When I send a request to get some data, it could be a video on YouTube or something. What that actually means is that, let's suppose I somehow got the code to render the YouTube web page, and then I click on the thumbnail for a video. Then a request from my browser is sent to the YouTube server, whatever that means. That means that I have a domain name which points domain name youtube.com and some detail which specify what I want from this specific domain. Then and that code is not known to my browser. That code that the fact that I am sending a specific request to YouTube is not inherent to my browser. That was specified in the YouTube code that I am presuming that I already have. Now, when I do that, what happens? Excalibur. Oh, yeah, shit, I was doing this. Um, wait, I have already done that. I have to want to disable this. I don't want like any request. Ah, fuck. Okay. Yep. Here. CDN and stuff. Right. My computer, this is my computer, it sends a request to youtube.com com, and in that request, if we are going really low level, what that means, what is it actually? Fucking, I don't know what that means. Sending a request, what does it mean? Um, my hypothesis is that it is a file that has quite a bit of text, and let's first of all suppose that I already have a hardware system in place which I can use to send and receive data over the internet, and I'm treating that as a black box for now. So let's just suppose that I have already a hardware system in place, and now since I am supposing that I can send a request from any one computer to any other computer which is connected to the internet, how do I specify the format in which we are supposed to communicate? I could be talking in English, the other person could be talking in Hindi or anything. So there are protocols which these can follow, right? And to specify that, I want to send a request to a specific computer. I need to have its IP, an IP address locks a computer. This tells exactly which computer it points to. And on that computer, there are multiple servers, multiple processes that are running. So in the computer itself, I have to specify a port on which the process is running. Now, different ports have different processes running on them, and the format which I am using to communicate can depend the format which I am using to communicate the format which I am using the format which I am using to communicate is also locks the port to which I will be sending a request. For example, if I am using the HTTP format, then I will be sending request to the port number 80 of the target computer. And if I'm using HTTPS, then I will be sending a request to the port number 443 of the target computer. Because I can suppose by convention, I can presume that if there is a service running on that computer, and we somehow have a mutual understanding that we are using the HTTP protocol to communicate, then by convention we will be running our services on port number 80. And if we are using the HTTPS request protocol, the format HTTPS, then we by convention presume that the other computer's server that handles HTTPS request is running on port number 443. That is cool, right? That much is clear. Now, youtube.com, I am sending, let's suppose, a HTTPS request. Now, I want to convert this string into a IP address, and since my laptop knows that the files, the service handling the distribution of the file is will be on HTTPS server, then I already can presume that the port will be 443. So I know the port, I want to know the IP address. How do I get to know the IP address? I ask a DNS server. A DNS server. A DNS is just a computer which is running a service computer, which is running a process on port number DNS runs on port number 53. On port number 53. Now, to do that, to send a request to port number 53 of a computer that is running a DNS service, I need to know the IP address for this DNS server. How the fuck do I know that? Let's see. Uh-huh. When sending a request over the internet to some domain, I want to, I have to know the IP that maps to that domain name. To get that IP, I can send a request to a DNS server, which means just a just a program running on some remote remote machine, which is listening on port number 53. Yep, 53, which is listening on port number 53 and has a specified DNS protocol, which protocol. Yep. Um, uh, yeah, I can do this. Ah, shit. Nope, not enough, not enough, not enough. 1, 2, 3. Yep. Paste, which has a specified protocol, which has running on port number 53. The DNS server to a DNS server, which has a specified DNS protocol, which has a specified DNS protocol, which that takes in a domain name string and returns the IP address that maps to that domain name, and the IP address, which is also a string that maps to that domain name, Now, how would I to send a request to such a DNS server over the internet? I would have to know the IP address of the DNS server. How do I know that? And also comment on how I described a DNS server, domain name service server. Yeah, let's see. Our description of DNS is mostly correct and well structured. You correctly stated that a DNS server is a program running on a remote machine listening on port 53. The DNS protocol is used to send a domain name and receive the corresponding IP address. To query a DNS server over the internet, you need to know its IP address. However, one minor refinement DNS responses don't always return just one IP address. Ah, okay. Depending on the query type, domain they can return multiple records. Example, A a records A records for IPv4, A for IPv6, CNAME for aliases. Okay, I will get into that what that A records and CNAME what this means. How do you know the IP address for a DNS server? That is yes. When you send a DNS request, you typically don't manually specify a DNS server IP. Yep. Instead, your system gets the DNS server's address from one of the following sources: your ISP, Internet Service Provider. When your device connects to the internet, your ISP assigns a default DNS server via DHCP, Dynamic Host Configuration Protocol. Okay, that is interesting. I have heard that before. DHCP, Dynamic Host Configuration Protocol. Example, if you are using Geo, how the fuck do you know that? GeoFiber, your router is likely to use the Geo's DNS servers. Okay, Geo has machines, computers on which DNS servers are running and listening on port 53. You can check this using this. Ah, shit. etc resolve. Uh-huh. Let's see. Mac OS notice this file is not consulted for DNS host name, resolution, address resolution, or the DNS query machine used by most processes on this system. To review DNS configuration used by the system, use this. Also see this file is automatically generated. Name server points to this, and name server also points to this local address. Why is it pointing to a local address? This is the address for my Wi-Fi. Ah, yep, the local address for my Wi-Fi. If I do name server http :// name server, if I do localhost 2. Okay, yep. Which will show which DNS server is being queried. This is the DNS server that is being queried. If I do this, download this, no, curl this, then curl 6, this, curl 6 http :/ this, and yeah, it has to have like square brackets. Yep, that is taking some time. That is cool, and I got some response, which is equally cool. There is quite a bit of response. Let me use Postman to catch it and view it. Ah, fucking hell. Postman. Things are getting a bit interesting now. Like DNS, yep. HTTP :/ this successfully updated to new version. That is cool. If I do this, I will get some HTML. Right, and preview. Oh, that just simply points to this. Okay, so if I even go to my browser, that points to my router. Is that a local address? I think local addresses begin with something else. Shit. I thought local addresses begin with if config en0 grep init. I thought local addresses begin with this secured copied 0b fe80. What do local addresses begin with in IPv6 8 FE8010 FE80. Yep. Mhm. They begin with FE80. Should I closed my terminal? Ah, where is item? If they begin with 0, if they begin with FE80, okay, let's go move on. My ISP can provide it, or my router. Most routers act as local DNS forwarders. Instead of every device manually knowing an external DNS server, the router gets DNS settings from the ISP and forwards all DNS requests from your local network. Manually configuring public DNS, you can overwrite your ISP's DNS server and use a well-known public DNS services like Google DNS. Is this? Uh-huh. Cloudflare DNS, Cloud Open DNS is at this. Wait, this is so. Does that mean that this IP address is shared by multiple computers all over the world, and those all of those computers run Google's DNS server on this IP address over port 53? Okay, same IP is shared by multiple computers. The operating system's local DNS cache. Yep, my operating system also has a local DNS cache, which is cool. The host files override DNS locally, look up locally before making an external request. Your system first checks hosts on Linux map, and in Windows it is in this. See if manually mapping exists. Right, hosts. Sudo / etc / hosts. Command not found. Oh, sudo nvim /etc /hosts, where these are the hosts. And let me do videosite.com. Like yep, let me do route something that points to my router 192 colon what was it, something that points to my router. Yep, this 192.168.29.1 192.168.29.1 that will be pointed by router. Right, if I go here and search router, it points here. Sudo nvim. If I go there and do router.com, will this work now? Router.com. Will this unavailable? Click to relog in. That does work. Click. Okay. So when I go there 192.168, what is exactly am I going to? When that is exactly it. If I just paste that here and this, okay, that is what I should point to, I guess. Router.com and yeah, fucking hell, nope. Nope, that is wrong. I have to just specify the IP and nothing else. Router.com. and that does point to my IP, to my router's IP. And there is a mistake. Platform.cgi. What the heck? Just go to the base URL. Ah, I'll come back to it. Now, your IP provides DNS servers automatically. My IP, ISP, or my router provides DNS servers automatically. I can manually set DNS server. Okay. Okay. ISP provides when your device connects to the internet, your ISP assigns a default server via DHCP. Okay. What is DHCP? What is DHCP? I have heard about DHCP before. I don't remember though. Something went wrong. Reason rate. Something went wrong again. Let's go DH. Fucking hell. Okay, I know what I'm going to do now. Yo, Chinese. Oh shit. That is too bright. Now that is okay. What does DHCP mean? Nah, I just want a normal response. Would it know that I am referring to the DHCP in computer networking? I guess it would know. And that is shorting a bit of time. Shit, that is taking quite a bit of time. What does, and go back to the chat custom services. Uh, what what does DHCP mean? Has it worked? Oh, ChatGPT is working. This is also here. DHCP stands for Dynamic Host Configuration Protocol. It is a protocol. It is a network management protocol used to automatically assign IP addresses and other communication parameters to devices on a network. To assign IP addresses and other network configurations parameters to devices on a network. Here is a breakdown of its key features, and ChatGPT wants to say quite a bit about it. DHCP is a network protocol used to automatically assign IP addresses and other network settings like DNS servers, gateway, and subnet mask. Okay, what is gateway and what is subnet mask? How DHCP works? Dynamic host configuration protocol. Host, that is a device which wants to access the computer, and it is dynamic because it can come on to the internet and it can go away from the internet, and this protocol helps in configuration of that host. So dynamic host, that is we have a dynamic host, we want to configure it, dynamic host configuration, and this is a protocol, dynamic host configuration protocol. How DHCP works: when a device like your laptop or phone connects to a network, it broadcasts a request asking for an IP address, a DHCP discover message. Yeah, okay. A DHCP server, usually the router. DHCP server. Yep, since DHCP is itself a protocol, there has to be a server that runs that protocol. A, DH, a DHCP server, usually the router, responds with an available IP address and other configuration details. The device accepts the offer and gets assigned an IP address for a specific period, a lease. Once the lease expires, the device must renew the IP address or request a new one. Why DHCP is useful? Eliminates manual configuration. You don't need to manually assign IPs to each device. Yep, devices can come onto the internet, go away. So every time that they join, they send a DHCP discover message. All right. And what do they use to send this DHCP discover message? Because they do not have access to IP address. They do not have an IP address. So, but IP address is what is required for a TCP protocol. But IP address is not something that this device has. So they must use some other protocol, which is DHCP protocol, I guess. And this DHCP protocol does not use the IP protocol. RFC, RFC, DHCP, RFC. Oh, that is pretty long. Well, of course, I'm not going to read this. The status of the demo. This document specifies an Internet standard track dynamic host configuration protocol. This document specifies an Internet standards track protocol for the Internet community and requests discussion and suggestions for improvements. Please refer to the current edition of the Internet Official Protocol Standards STDs. Okay, Internet Official Protocol Standards. What does T stand for? And what does S stand for? S comes at the last. And what is D? Standard STD, or STD is just a standard. For the standardization state and status of this protocol, distribution of this memo is unlimited. Anyone can distribute this. DHCP provides a framework for passing configuration information to hosts on a TCP/IP network. DHCP is based on the Bootstrap protocol, BootP, adding the capability of automatic allocation of reusable network address and additional configuration options. DHCP captures the behavior of Bootstrap protocol, relay agents, and DHCP participants can interoperate with Bootstrap protocol participants. Okay, DHCP is built on top of something called Bootstrap protocol. Why DHCP is useful? And broadcast request DHCP server. Once the lease expires, the new IP address must be requested. Why DHCP is useful? Eliminates manual configuration. Yeah. Prevents IP conflicts. Ensures no two devices get the same IP. Makes networks more scalable. New devices can connect seamlessly. DHCP and DNS. DHCP doesn't just assign an IP, it also provides default gateway. The IPs, the routers, default gateway. Okay, default gateway is the router's IP address. Subnet mask for defining the local network. Subnet mask that defines the local network's range. Okay, range in like the IP address beginning from this to this. All of the IP addresses in between are in the local area network. DNS servers for so your device knows where to send DNS queries. For example, when your GeoFiber assigns you an IP, it also tells you your device which DNS server to use or a public one like Google's. Okay. Hmm. Okay. When a new device is connected to the internet, it sends out a DHCP discover request, which is based on the Bootstrap protocol, and the return message of that request specifies the default gateway, which means the IP for the router, then subnet mask, which specifies the range of the local area network IP addresses, and and it also specifies the DNS servers that the device can use. Now, if we are doubling down on DHCP, do I want to double down on DHCP and go even deeper on DHCP? That is when a device is newly connected to the internet. What happens then? How does it gets how does it get a IP address and stuff? Okay, let me describe the DNS for ChatGPT. DNS uh, D DHCP is just a protocol that okay, what is the code for DHCP? DHCP port is 67 for the server and port 68 for the client. Okay, it's just a protocol uh, that a server running on port 68 uses, and the server receives a message um, and from a newly connected device which wants to get an IP address and other configuration details, which requires an IP address and other configuration details. The DN DHCP server looks into the available IP addresses that it has, and along with one of the IP, it sends back to the client a subnet mask and and default gateway. Default gateway. Here, subnet mask is just a range of IP IPs which belong to the local network, and default gateway is another IP which points to the router. Let's see. You are very close. Your explanation is mostly correct, but here are a few refinement. Okay, the port number, that is understandable. The DHCP client your device sends a request to port 67. 67 runs so the server runs on port 67. The DHCP server replies on port 68. The client runs on uh, port number 68. That is understandable. Subnet mask clarification. The subnet mask does not define a range of IPs directly, but instead defines which part of the IP address belong to the network and which part belong to the host. Which part of the IP address belong to the network and which part belong to the host. Example, subnet disk. This local network range, the router is this all devices. This belong to the same local network. Okay. For my default gateway is the IP of the router on the local network. It acts as a middleman that forwards traffic from local devices to the internet when the destination IP is outside the local network. When the destination IP is outside the local network, for example, if your device gets this and the default gateway is this, right, all traffic going to the internet is sent through this first. Oh, default gateway, that is to whom I first send the request that I want to send out to the internet or wherever. All of the requests go through the router, which is self-explanatory. No, not, nope, it is not that simple. Local network range, if the router is this, oh, it's subnet mask. The subnet mask means that these are all of these four, how many bytes, all of these, this whole byte is 1 to the max. This is also 1. This is also max 1. And this is 0 that I would suppose is that it can change. Submit this. Okay. Before reading on further, I'll ask about this. Here, the whole IP takes up 4 bytes, and the first 3 bytes have all ones, and the last byte is all zeros. Um, does that mean that the bits that are 1 are fixed fixed in the default gateway IP, and the bits that are zeros can change, and if the fixed bits match if the fixed bits match if the fixed bits match the default gateway IP, then no matter what the zero what the flexible bits are, the computer will know that the target IP is under the local network. Question mark. Mhm. When the subnet mask, that is a mask. That is why it is called mask. It means that the first 3 bytes, 24 bits are all ones, meaning they are fixed, and define the network portion. The network portion of the IP, the last byte, 8 bits, is all zeros, meaning they are flexible, and define the host portion, that is individual devices in that network. What this means for local network detection: if your default gateway is this and your subnet mask is this, then the network address is this, meaning all IPs from this to 254 belong to the same local area network. 24. If your computer sees a destination IP starting with this, it knows that the target is inside the local network and will communicate directly. If the target IP doesn't match in the first 3 bytes, example, this, then the computer knows it's outside the local area network and sends the request to the default gateway, the router, to handle it. Okay, if it is under the same network, I can send request directly, which does not go through the router and then to the device. That is interesting. I didn't know that. Okay, if the device is under the local network, if the target device is under the local network, then I can send a request directly to it. Uh, does that mean I don't have to send a request first to the router, which forwards it to the target device? Uh, to the target device, and if my interface uses Wi-Fi, then I will be communicating with the target device directly as if the router didn't exist. That is a crazy theory. Yes, exactly. Fucking hell. I can communicate. What if the devices are connected through Ethernet and cannot communicate directly? Then they would have to communicate through the hub. Shit. Even then, if every device is communicating through the hub, then there has to be a DHCP server running on some device, and that device can either that server can either be running on a host computer, which will be seen as a host and the router for that whole network, or can be running on the hub itself if the hub is smart and intelligent. Okay. Yes, exactly. If the target device is within the local network and both devices share the same subnet, your device can communicate with the target directly without needing to send the request to the router first. That just does not seem possible. That seems just ChatGPT is lying. Communication with the same local network target device on the same subnet. When both devices are on the same subnet, example this and this with subnet mask this, your device will send packets directly to the target device without involving the router. This happens because the both devices can reach each other with using their IP addresses directly on the local network, so the router is not involved in this communication. Okay, that seems like magic. That two devices can communicate directly without a router. That would be somewhat similar to how Bluetooth speakers are connected with a mobile device, or how I communicate with my television using a remote. They are directly communicating, direct communication using Wi-Fi. If your device is connected via Wi-Fi or Ethernet, and the target device is also on the same network, they can communicate directly with each other. This happens within the local area network LAN, and the router is not involved. Router is not involved. Okay, I guess my definition of a router is overlapping the definition for a hub. Right, I guess that is what is happening. A router is used to send a reroute a request to something, but a hub is used, but a hub is used to make multiple devices be able to communicate with each other over the same network. I guess my definition of a router is not up to the mark. This happens because both the devices can reach each other using their IP address directly. Direct communication over Wi-Fi. If your device is connected via Wi-Fi or Ethernet and the target device is also on the same network, they can communicate directly with each other. This happens within the local area network LAN, and the router is not involved in the data transfer. The router's primary role is to connect devices, a hub on your local network, to external network, the internet. But for communication between devices on the same network, the router does not need to forward packets. The router's role, router involvement for external communication. It is used to reroute the requests to external internet to the internet. If the target device is outside the local network, right, then the request must go through the router. That is, when the destination IP address doesn't match your local network's IP range, the subnet mask over applied over the default gateway. In this case, default gateway, it is called gateway because it is through which I can communicate with the internet. I open the gate and through it I can communicate with the internet. And that is, I can have multiple gateways, but my router, that is a very peculiar statement, I guess. The router in my device, in my home, to which my device is connected, acts as a router. Okay, I guess multiple definitions of router are mixing up, and that is what is causing the problem. Today, the definition for a router is seen as a device which provides internet. But a router, in the context of networking, is something that takes in an incoming request, sees the target IP address, and forwards that request to another router which is closer to that IP address, and it knows to which router to forward the request to through a table the which stores which router are closer to what IP addresses. That table is called a routing table, and it is based on it uses the D-scra algorithm to find out the fastest path between two IPs. Okay, not between two IPs, between the IP of the current router. Oh, shit, yes, routers themselves must have IPs, right? Yeah. Between the IP of the current D-scra algorithm is applied where the source is taken as the IP of the current router, wants to find out which wants to find out the connection routing table for itself, and target device is the whole fucking internet. In this case, the router will act as a gateway to forward the request to devices on other networks or the internet. Summary of local area communication. Yes, if both devices are on the same subnet, they can communicate directly without involving a router. Okay, okay. First, let's get clear about local area communication. Mhm. If two if two devices are on the same local area network, it means that they are connected. It means that they are connected to each other through some kind of hub, and I want it to be capital, through some kind of hub. A hub is just a just a device takes that takes in connections from multiple devices and connect and makes pairing between all the possible pairs, and those connections can be either using physical wires or wireless, like Wi-Fi. Now, a hub is different from a router, right? A hub is different from a router. A hub connects devices directly. A hub connects devices directly. What is a good analogy for a hub? Where multiple things come and everything is paired with everything else. Mm, if n devices are connected hub to a hub, then the hub makes how many pairs? N factorial? Fucking hell. N factorial. Is that correct? N factorial. And the first one has n minus 1 factorial, I guess. And then the hub makes n minus 1 factorial connections between all the devices. And when two devices are connected over a hub, when two devices are connected over a hub, they can communicate to each other. Now, how do they communicate with each other? Is something that I want to know. But wait, before getting into the weeds, I want to know if this much is correct, that this is a hub. A hub is different from a router. A router takes in a router itself has an IP IP address. Itself has an IP address, which is used by other routers or by a client or server device to send a request to it, and the router on receiving a request sees the final IP that the request has to go to, and forwards that request to forwards that request to a router which is closer to the target IP. The first router that a client sends its request to is called the default gateway. A hub connects devices locally directly, and a router is used to forward forward requests over the internet. See, you are on the right track. However, there are some misconceptions about how hubs switches are. What the heck? Switches and routers work. Okay. Hmm, it is stuck. Shit, it has been stuck and I was typing so much. Let me fix that. Look lonely, I can fix that. Yeah, yeah. Like hell. No, no, thank you. Yep. So, this is what I wrote to ChatGPT, and this is the response that I got. Shit, the response is not that big. Let me open YouTube on my phone so that if there is any chat, I will be able to see it. No, 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 no. Yep. Change device. Change account. Not change device. Andrew Huberman is a cool guy. He talks about different amazing stuff. Yep, it's cool. Yeah, okay, that is cool. I can see myself and I can see if there are any chats. Live chat, that is. Wait, where are live chats? Yo, yep. If there are any live chats, I will be able to see them. Before that, first of all, I would like to go to the washroom for a minute or two, and then we will continue our journey. And I'm back. We just continue. Hub, switch, router. Yes, you're on the right track, but there are some misconceptions. Hub. What is a hub? A hub is a simple network device that connects multiple devices where is Bluetooth. Bluetooth is connected. Um, Noise cancelling is on. Okay. Instead, it broadcasts every incoming packet to all devices. It does not make n minus one factorial connections. Okay. It broadcasts every incoming packet to all devices connected to it, meaning every device receives all data, even if it is not meant for them. This is inefficient because it creates network congestion. Every device must filter out the data not meant for it. What is a switch? A switch is an improved version of a hub. Instead of broadcasting data to all devices, it learns MAC addresses and forwards packets only to the intended devices. This reduces uh, unnecessary traffic and improves efficiency. Most modern networks use switches, not hubs. Use switches, not hubs. What is a router? A router is different from a hub or switch because it connects different networks. Example, your local network to the internet. It has an IP address because it participates in a routing data. When a router receives a packet, it looks at the destination IP address and forwards it to the next router or the final device. The default gateway is the first router that a device uses to send traffic outside the local network. Key difference. Hub function connects multiple devices in a local network, connects multiple devices efficiently, and a router connects different networks, right? And broadcasts all incoming packets to all servers, right? Learns MAC addresses and sends packet only to the intended devices, forwards packets based on IP addresses to reach external destinations. To reach external destinations, yep. Verifying your definition, your general idea is correct, but there is a correction version. A hub is a basic network device that connects multiple devices in a local network, but it broadcasts all data to every connected device, making it inefficient. A switch is a smarter version of a hub that forwards data only to the correct devices, improving network efficiency. A router is responsible for forwarding traffic between different networks. It has an IP address and acts as a default gateway for devices in the local network. Okay. Okay, so the router to which my device is connected to and the other devices in the local network are also connected to also acts as a switch when some requests needs to be sent to a device locally. So that was where the definition of a router was messing up. Yep, it acts as a switch when I want to send a request to a local device. So when sending a request over the local network, I send the request to my router, which now acts which now acts as a switch and forwards the request to the target device in the local network. Is that correct? I guess that is correct. Yes, your router acts as both a router and a switch in a typical home or office network. Here's how it works. Router has switch local network communication. When your device wants to communicate with another device on the same local network, it does not need to route the request through the internet. Instead, your device sends the packet to the router. Since the router is managing the local network, the router acts as a switch, clicking the destination IP MAC. Clicking and the router acts as a switch, checking the destination IP address or MAC address and forwarding the packet directly to the target device without sending it to the internet. Without sending it to the internet. All right. Key point. Your router behaves like a switch when forwarding packets inside the local network. Router as a router, internet communication. When your device wants to communicate with a device outside the local network, example, a website on the internet, it sends the request to the default gateway, the router. Default gateway, the router is the default gateway. The router then forwards the request to another router, typically your ISP's router, which continues forwarding the request until it reaches the final destination. This is final destination. This is simple, elegant, eleganto. This is simple, 10 billion% simple. Key point, your router behaves like a router when forwarding packets outside the local network. So, what I am understanding is this. What my stupid brain is able to understand is this. My my device. Let's say, and right now we are just talking about how data is transferred between two devices, and let's suppose that I already have the destination IP address. So I have a destination IP, right? And I have a request that I want to send to that destination IP, which is here. This is the destination computer. I want to send a request from this to this. Now, since I know that the destination IP, I can check it with the subnet and the default gateway router, the default gateway that this request, this IP falls outside of my local network. Therefore, I will send my request, this request R, and send it to my router. How do I know the IP address of my router? The IP address of my router is just my default gateway. Gateway to access the internet. My router takes in the request and it sees the destination IP address and it takes the request and does not change anything with the request. It just takes the request and sees the destination IP which is inside the request and sees it has a routing table and sees in that routing table that to reach this destination IP to which next router should the request go to reach this destination IP in the fastest way. Then this request is sent to another router and yep, what does this mean? Sending a request from a router to another router. I sent my request from my device to the router because I knew the default gateway, but my router sees the destination IP and has to send a request to a router which is closer, physically closer with the destination IP address. And if that is the case, physically closer with the destination IP address. Yes, physically closer. So it has a table, and in that table, it knows that if the destination IP range falls between some range, then there is a IP of a router to which the request should be sent. And if it falls between some other range, then it has another IP for that. So it just matches up with the table and finds the IP of the next router, which then does the same thing and sends the request to another router, and which in turn does the same thing and sends the request to another router. And let's say we have reached the final router at this point, and this device that we want is wait. What do I mean by final router? The final router is the default gateway for this device, right? Yep, it has to be the final gateway for this device. So let's say a default gateway. There is a default gateway router for this device. Let's say this router does the same logic that has been running throughout all the routers till now and sends the request to the default gateway for this device. And the default gateway sees that the request has the IP address for this device. How does it know that? Because this device has a global IP address. Yep, this device has a global IP address. Thus, the default gateway, that is the router, can determine that the destination IP points to this specific device and sends the request to that device and tells that this IP, a device with IP this and this, sent has sent a request to you and process it or do whatever you want. And if the destination IP address, the device at the destination IP address wants to send a response, it can see the origin IP address and run the whole process again and send back a response, which will reach our device. And fucking hell, let me get a charger. Yep, got it. And shit, I was about to die. Wait, it said OBS using significant energy. Shit. I can see energy. It has 56 threads. That is quite a bit. And ports. Wait, is this the number of ports that it is using or the port that it is using? And the whole OBS is running on a single process ID. That is also crazy. And the memory it is using is this much. Wired memory, compressed, close. And yes, you guys can hear me. Now, where were we? Yep. To send a request from one device to another and then back. Back like that. Hmm. Okay. Right. Right. So in this whole structure, two things that I presumed was that my device knows the destination IP. Yep, that is the only thing that I guess I presumed. And My device knows the default gateway, yep, and also the subnet mask. And all three of these my device comes to know when it connects to the internet and uses the DHCP protocol, dynamic host configuration protocol. And it's my device when it first gets on to the internet, that is, it connects to a router to get a IP of its own. It then just sends a DHCP request through the interface that it is connected to, and that request hopefully reaches our DHCP server, and that DHCP server gives back an IP address, a subnet mask, a default gateway, and a DNS server IP address, so that I can map domain names to servers, domain names to IP address. Like I can call the DNS server and ask what IP address does it point to. Yep, how switch part. We did that, right? The switch part is responsible for managing traffic. Nope. Wait. So a router to which when you're yeah. Router as a switch local area network. When your device wants to communicate with another device on the same local area network, it does not need the router to request through the internet. Instead, your device sends the packet to the router. It doesn't need the router to send a request through the internet. Instead, your device sends the packet to the router. Since the router is managing the local network, the router acts as a switch, checking the destination IP MAC address. Yeah, router as a router. Yep. Home router functions internally. Your router actually has two main parts inside it. The router part, responsible for connecting your local network to the internet and forwarding packets between different networks. The switch part, responsible for managing traffic within local network, forwarding packets only to intended local devices. Most home routers have a built-in switch with multiple LAN ports, Ethernet, and Wi-Fi capabilities, so they automatically handle local, both local and internet traffic efficiently. Right, so to connect to the global network, to the local network, I can either use Wi-Fi if my device has a Wi-Fi, or I can use Ethernet, which is amazing. I have an old laptop which I can open up and get out the motherboard and use it as a Raspberry Pi. That would actually be fucking cool. If I were using my old laptop, open it up and put it in a new case and using it as a Raspberry Pi. That would be fucking awesome actually. And then I can connect it to my router through Ethernet and use it to control different things throughout things. Like I can make my printer wireless. It is not currently wireless, but I can make it wireless if I do that. Okay, I might make a series on that, and I can make remote control fan or lights by putting a GPIO on my so-called Raspberry Pi, my own local board, local version of it. That would be fucking cool. Okay, what do I understand? That there is a switch which is used to connect devices over a single local area network, and there is the router which is used to connect different local area networks. Right. Right. So every device, when getting on the internet, which means that it has gotten an interface through which it can send out requests, which are just messages, which means that it has gotten an interface through which it can send out requests. Requests are just messages, right? Uh, when a device gets a new interface, it sends out a request which adheres to the DHCP protocol, which adheres to the DHCP protocol. The request is expected to be pro to hit a server which is running a DHCP um, program, or to hit a computer, to hit a machine that is running a DHCP server, and the request is then processed there in the server's own ways, and configuration details are sent back to the device which initially sent the request. The device on getting a response for its DHCP discovery request, getting a response for its DHCP discovery request, unpacks it and uh, decides whether it will accept the configuration details or not, and then accordingly sends back an accept or reject message to the DHCP server. Right. Yes, you have captured the essence of how DHCP network work. Uh, let me define and structure your explanation a bit more. What happens when a device connects to a network? When a device gets an interface, this means the device now has a way to communicate wired or wireless. Device doesn't have an IP address yet, so it cannot communicate properly on the network it sends. Why does it need to have an IP address? Because the whole internet uses IP uses TCP/IP protocol to communicate and send data, and on top of that, majority of it is HTTP, which comprises as together with TCP/IP and HTTP and HTTPS comprises of the web, World Wide Web, and also the DHCP and DNS protocols. Device doesn't have an IP address yet, so it cannot communicate properly on the network. It sends a DHCP request using the DHCP protocol to ask for network configuration details, IP address, netmask, default gateway, DNS server, etc. The DHCP process, DORA. The DHCP is in 4 steps called DORA process. Discovery, DHCP discovery. Broadcast. The device broadcasts request to find a DHCP server. Since the device doesn't have an IP yet, it sends the request to this broadcast address. Uh-huh. And this message is like, hey, is here a DHCP server out there? I need an IP. And oh, offer, Dora. Discovery, oh, offer. DHCP offer a DHCP server. If present, receives the discovery request and replies with an offer. The offer includes an available IP address, a subnet mask, a default gateway, a DNS server, a lease time, how long the device can use the IP before renewal. Okay, the message is like, hey, I can give you an IP this. Let me know if you want it. R request Dora discover offer and now request. The device chooses one of the offers. It sends multiple offers. Okay, the device chooses one of the offers if multiple servers responded. Oh, if multiple servers responded and one server only sends one offer, it sends a request back to the DHCP server saying, I would like to take this, please confirm. And A, acknowledge. Dora, discover offer request acknowledge. Discover offer request acknowledge. It requests to the DHCP server saying, I would like to have this. Thank you. The DHCP server finalizes the lease and responds with acknowledge. The DHCP server sends back acknowledge. Okay. The new device now officially owns the IP starting with it. The message is like, all right, this is yours. Enjoy your internet. Can a device reject the DHCP offer? Yes, the device can reject an IP if it detects an IP conflict, that is, another device is already using it. It doesn't like the configuration, example, wrong gateway. It already has a preferred IP address from previous connection. The lease time is too short for other settings are incompatible. In that case, it can send a DHCP decline message saying, I can use this IP, or restart the DHCP process by sending another DHCP discover. Final refinement of your correct version. When a device gets a new network interface, it needs an IP address to communicate. It sends a DHCP discovery request, which a DHCP server receives and processes. The server responds with an offer containing network configuration details. The device evaluates the offer and either accepts or rejects it. If accepted, the DHCP server finalizes the assignment and the device starts using provided network settings. That is how I get my device gets a default gateway, an IP address, a DNS server IP address, and a subnet mask, a lease time. All right. So devices running a DHCP server run the DHCP program on port 67, and the interface that they use for this server always has the IP address 255 or 255. See, not exactly. There are a couple of misunderstandings here. Let me clarify. What does DHCP server runs on 67? That is cool. And DHCP client requests from port 68. Does a DHCP server use this as its own IP? No, a DHCP server has a real IP address on the network, like this or any valid IP. This is not a DHCP server. It is a broadcast address used by clients to find a DHCP server. So if I am sending a request to this address, then it will go to every device. Does your client find a DHCP? How does your client find a DHCP server? Since the client doesn't have an IP, it doesn't know where the DHCP server is, so it sends a DHCP discover message to this. This means broadcast. This means any DHCP server out there, please respond. This is a broadcast. Well, this does not mean this. This is the message that is being sent to this IP. Every device on the local network receives this packet, but only a DHCP server responds. Okay, every device gets it. Once the client gets an IP, future communications don't go directly to the DHCP server's real IP. Example is uh, when does this get used? Only for initial DHCP discovery because the client has no IP. After that, the client communicates with DHCP server directly. Incorrect. Devices using a DHCP server run the DHCP program on port 67, and the interface that they use for this connection always has the IP address. Devices running on a DHCP server listen for requests on port 67. That is what I said. On port 67 using the UDP protocol and have a really static address like this that clients that don't have an IP yet send their initial DHCP request to a broadcast as a broadcast to this, and the DHCP server responds with this. Okay, so if I send a request to a switch through which I am connected to a local network, and the IP that I use is 255.255.255.255, and then the switch will send that request to every device connected on that local network. Yes, but let's refine that a bit. What happens when you request to this? Your device sends a broadcast packet. What is broadcast packet? This layer, this is a layer 3 IP broadcast, meaning it is meant for all devices on the same subnet, internet subnet. Example, if your device doesn't have an IP yet, it might send a DHCP discover packet. Fucking hell. It's been too long learning about network. It's been 2 hours since I started learning about networks. Okay. Yes, well, at least I have to get clear with this, and then I can end the stream and take some break and continue learning on my own without the stream. Example, if your device doesn't have an IP yet, it might send a DHCP discover packet this way. The switch, if an unmanaged basic switch, floods the packet to all devices. Switches operate at layer 2, Ethernet or MAC. Okay, two things. What is MAC? And they don't look at the IP addresses. Uh-huh. Uh-huh. Switches operate at layer 2, Ethernet or MAC level. They do not look up the IP addresses. Since this is a broadcast address, the switch forwards it to every device and the same layer, except the sender. Yes. Every device on the network receives the packet, but only relevant devices respond. For example, only a DHCP server would respond to a DHCP discovery. Yeah, all the other devices will just ignore. Other devices might ignore it unless they are running a service that listens for a broadcast package. So it uses 67, right? Uh, Projects, YouTube stuff. If I change the port to 67, yo, uh, client server to server listening on port 67. So now I have server running on port 67. That is good. Let me go cd projects YouTube stuff and client.c. Change the port here also to 67, right? Yep. And yes, I also have to change, update the IP address. The current IP address is if config en0 and like grep. What do I want to grep? I want init 6 and this I can use this one. The hic that is the prefix. Wait, I have three of them. That is, this one is secure, this one is depreciated, auto config, and auto config temporary. Let me use this one and client.c and update the IP here. Wait, what? This is similar to the last one. Clang client dot slash client. It does work. It does work. Connection accepted. Request is hello server from client and response sent. Okay. All other are ignore and only DHCP server response. No, a router does not forward packets sent to this across networks. Broadcasts are limited to the local network subnet unless configured otherwise. Example DHCP relay. Okay, so every subnet has a DHCP server running on one of the connected devices, and now the DHCP server generally runs on the router, home router. Question mark. Yes, in most home routers, the DHCP server runs on the router. So the router acts as a router, as a switch, and runs the DHCP server. That is cool. Where does the DHCP server run? A DHCP server must be present in every subnet to assign IPs to devices that in that subnet. It typically runs on. I can make my own DHCP server or make my own like fucking just the software part of networking can be made by me, and from that I can trickle down into the hardware level and design my own network. Fucking hell. I can communicate, I can connect devices and make things happen from a distance, action from a distance. That is cool. In a typical home setup, your Wi-Fi router acts as a DHCP server. It assigns IPs like this to all connected devices. Yeah. Enterprise networks, a separate DHCP server. In large networks, DHCP is often run on a dedicated server, not router. Okay. When there is no DHCP server, devices use API-PA, automatic private IP addressing, to assign themselves an IP in this range. This allows local communication but no internet access. What if there is no DHCP server in a subnet? Since routers don't forward broadcast packets like DHCP discover across subnets, if a subnet doesn't have a DHCP server, devices there won't get an IP unless a DHCP relay agent is set up on the router to forward requests to a remote DHCP server. Devices are configured with static IPs manually. Okay, that is how a device gets an IP address. With that much is enough for now, I guess. Yeah, uh, quite a bit of information, and it needs time to process. DHCP servers router, switches, hub, and yeah, DHCP server, router, switches, hubs, and stuff. It is interesting. I have a few questions like, what if I am communicating directly through my mobile internet without connecting to a router directly to a network tower? I guess in that case, when I broadcast a DHCP discover request, then that request reaches all the devices in the vicinity, and one of them is hopefully a DHCP server or a router which sends that request out to a DHCP server. Or maybe phones come with a static IP address. That could also be it, like with a SIM.